Hi everyone, today we're going to be doing 3.5 dividing integers. This is day 2. We're going to be focusing on word problems today. So today we're going to be focusing on word problems, and the first read, I just want you to read it through, and then we're going to try to explain it without any numbers and operations to get us a better idea of what this is about. And then we can pull in the operations and put that stuff in there. So let's go ahead and read. So 1 year, the estimated Australian koala population was 1 million. After 10 years, there was about 100,000 koalas. Find the average change in the koala population per year. Then explain its meaning. When you come to a word problem, the best thing is to read it and then read it again. So what I like to tell students is first read it through one time and then read it again a second time. And then after that read, you should be able to explain what this word problem is without numbers. If you can't, then you can go back in and try to figure it out. And then the fourth is to explain with the operations. So we've read it one time, so now we're going to go ahead and do the second read. So 1 year, the estimated Australian koala population was 1 million. After 10 years, there was about 100,000 koalas. Find the average change in the koala population per year, then explain its meaning. So I'm going to go ahead and explain this without words. So there were a lot of koalas, and after so many years, there was not as many koalas. And we need to find the difference or the change in the population, or how the koalas changed over each year. Okay, now I'm going to explain with the operations. So I see, I'm going to first highlight some important facts in this word problem. I'm going to go ahead and highlight. So I see that there is 1 million koalas to start with, and then it went to 10,000. So I have to find, it says the change, okay? So the change in the koalas. And then another piece of information is that it happened over 10 years. I have to see what is the difference between the amount of koalas that changed. Well, did my koalas increase or decrease? Well, they decreased, right? So I need to show that decreasing. So my answer should be a negative answer. So right now I have 100,000 koalas, but I used to have 1 million. So I need to find the difference of the koalas, or that means the operation is I need to subtract. And then this is saying that it's after 10 years. So this didn't happen just in 1 year. It was 10 years. So this is over 10 years. And it does say per year. When it has per means to divide. Okay? So that's usually what per means. So if I have 100,000 minus 1 million, that would give me negative 900,000. And that would be over 10. And if I continue that, then I would get that equal to, I guess I should put it down here, negative 90,000. When you divide by 10, right, just a zero will just be taken off. Okay, so what does this mean? So then it says explain this meaning here. So what does negative 90,000 mean? Well, it means the koala population has changed by negative 90,000 per year. So I'm going to go ahead and write that. So here's my answer in a sentence. So the koala population has changed by negative 90,000 per year. So that means every year they're losing 90,000 koalas. Let's go on to the next problem. First up that I want to do is read my word problem here. So the average temperature in January for North Pole, Alaska is negative 24 degrees Celsius. Use the expression 9C plus 160 over 5 to find this temperature in degrees Fahrenheit. Round to the nearest degree, then explain its meaning. Well, this isn't as hard because they give me an expression. So now I just need to reread to see what do I do with these numbers here. So it says the average temperature in January for North Pole, Alaska is negative 24 degrees Celsius. So I'm seeing that the C here is Celsius. All right, use this expression to find this temperature in degrees Fahrenheit. Round to the nearest degree, then explain its meaning. Well, what does this mean? Well, this is the temperature in degrees Fahrenheit. So I will be changing. So now I'm explaining it in my own words without using numbers. I'm changing this negative 24 degrees Celsius into Fahrenheit, which that's the temperature that we normally use here in the US. So I'm going to go ahead and I'm going to highlight my important numbers here that I need to find here. So I'm going to go ahead and take that information. So I'm going to plug this in here. Okay, so this is going to be the Fahrenheit degrees, right? Is equal to 9 times C, or the Celsius, which is negative 24 plus 160. Divide that whole thing by 5. Now I'm going to go ahead and multiply that. Okay, when I multiply 9 times negative 4, I get negative 216. And then I have to add 160 to that, divided by 5. My signs are different. I have positive 160 and a negative 216. That means I subtract the 2, right? Because I'm becoming more positive here. So it would be negative 56 because there's more negatives. So really I did 216 minus 160 in my head. Subtract that, and I get 56, but it's going to be a negative because there's more negatives. And then I have to divide that by 5. And negative 66 divided by 5 is about 11 degrees Fahrenheit. Okay? So what does this mean? Well, that means negative 24 degrees Celsius is about 11 degrees Fahrenheit. That is my answer. Okay, here's our last problem. So the boiling point of water is affected by changes in elevation. Use the expression negative 2a divided by 1,000, where a represents the altitude in feet, to find the number of degrees Fahrenheit at which the boiling point of water changes at an altitude of 5,000 feet. Then explain its meaning. So that means, so I need to reread it because I need to re-clarify. So the boiling point of water is affected by elevation. So that means that depending on how high and how low I go, like maybe I'm going to the mountains or I'm going to the beach, the boiling point is going to be affected, or it will change depending on where I'm at, okay? And it says to use this expression where A is the altitude. Okay, so I am given to find the number of degrees Fahrenheit at which the boiling point of water changes the altitude at 5,000, and then explain its meaning. So right now I'm just going to explain without any numbers. So what I have to find is the boiling point of water at Fahrenheit depending on the altitude. So that's what I need to do. So I'm going to use this expression, negative 2a over 1,000. And I'm going to, where a equals 5,000. The altitude is 5,000, right? So I'm going to do negative 2 times 5,000 divided by 1,000. And that is equal to, well, negative 2 times 5,000, that would be a negative times a positive is negative 10,000. Over 1,000. Well, I'm dividing by zeros. When I divide by zeros, I like to cancel out my zeros. And then I'm just left with negative 10. But what does that mean again, right? Well, we said that it was where the boiling point of water changes, right? The degrees Fahrenheit, though, okay? So the boiling point decreases because it's negative 10 degrees Fahrenheit when it's at the altitude of 5,000. So I'm going to go ahead and write that out. So I just wrote that out. I just said the boiling point decreases 10 degrees Fahrenheit at an altitude of 5,000 feet. All right, that's the end of 3.5 day 2.